welcome to another library lesson. We are starting a new unit today, so we're moving away from coding now, and we're going to be starting engineering. So we'll be reviewing the engineering design process and getting ready for our design challenge coming up soon. You should have received one of these kits, and I don't want you to dig into those yet. Just save onto those because we're not quite ready to jump in them yet. If you are a remote student, those are all right out front and ready for you to pick up at this time. All right, we're going to be reviewing the whole process and watching a brain pop video. So let's go ahead and get started.
Chewing food. Everybody hates it. It's messy, complicated, and unsanitary. Is this the future we were promised? Hi, I'm Flip Fauntleroy, the inventor of Chew It. It's got 6 utility patents and it straps directly onto your existing face.
Him? Really? He probably didn't even invent that contraption. Dear Cassie and Moby, how do people come up with great inventions? From Mrs. Lambert Magus's science class. I like the way you're thinking. Great inventions rarely come from one big burst of inspiration. More often, inventors solve problems by following a series of steps. It's called the engineering design process, or EDP, and anyone can learn it. People break it down in different ways, but I think of it as 6 main steps. Identify, imagine, plan, create, test, improve. You can use it to create brilliant inventions that'll change the world. Or for little things, like how to keep your cat off the kitchen counter. The solution isn't necessarily a physical product. Processes, like improving the recipe for a medicine, are designed too. No matter what form they take, useful solutions almost never come about on the first try. They emerge through iteration, repeating the engineering design process over and over. Take the light bulb, an invention that changed the world. Eventually. Thomas Edison often gets credit for it. But he didn't exactly invent the light bulb, he improved it. The invention of the light bulb started with identifying a problem that needed solving. In the late 1800s, it was finding a cheaper and safer alternative to candles. Electric lamps existed, but they were extremely bright and flickered like crazy. Inventors imagined how they could use electricity to light people's homes, and worked on plans for a more practical electric light. Running electricity through a filament would make it glow without flickering. While they were able to create working light bulbs, there was a major flaw. Testing revealed that the filaments burned out in minutes. Still, there was clearly potential in this design, which is where Mr. Edison came in. He and his team set out to improve the filament by using different materials. Over and over again, they repeated many of the EDP's steps: imagine, plan, create, and test. They tried more than 6,000 materials and found that bamboo worked best. The bamboo filaments lasted for over 1,000 hours. It took endless iteration, but at last, they designed a practical light bulb. Yeah, the EDP can be a lot of work, but it leads to great solutions. Like when I got to be part of the team that built the SS Cuttlefish, our prize-winning entry in the 7th annual all-neighborhood raft race. We knew there'd be strong competition, so we needed a great design. For more than a week, we met here in the garage every day to work on it. During the identify step, we made a concept map with our problem in the middle and broke the problem down into smaller parts. Like, a successful raft can't have leaks, so we needed waterproof materials. We also wanted a design that moved through the water quickly. Those were some of our criteria, specific goals that our design needed to achieve. The rules of the race gave us one more criterion. The raft had to be made of household materials. We also had to consider the constraints or limitations on the design. You couldn't spend more than $50 on materials. And you had just 10 days to design and build the thing. All this preparation helped inform our next step. We researched materials that fit our criteria and constraints. Research is so important that some people think of it as its own step in the EDP. Looking at existing designs for rafts also helped us pick an approach. Nope, our first design still failed. We forgot to consider the total weight the raft needed to carry. In our next iteration, we refined the problem to include this criterion. We were running out of time, and we'd used up our budget on the first design. So that's how we ended up with this model. You know, I didn't ask why Tim had so many rubber ducks. But I have a huge Kitty Ranger collection, so who am I to judge? Anyway, we did more research to figure out how to solve our flotation issue. We ran some tests on our materials and read up on buoyancy. That's the scientific principle that explains how much floating power an object has. It helped us figure out how many ducks we needed to stay above water. Then, we imagined how we could lay them out and sketched out our plan. To make sure everything fit together properly, we made a scale drawing first. It took time to create, but it saved us from making any mistakes when we built our new prototype, a working model of the design that lets you test it out. Well, it worked at first, but then we started losing ducks left and right. Our frame held up this time, so we kept that part of the design. But our flotation system was way too complicated. We needed something bigger than duckies, and more durable than garbage bags. Rita came up with using some big buckets with tight lids. Brilliant! We went through the rest of the EDP, and this design finally passed our test. Our design wasn't as flashy as some of the other rafts that entered the race, but that's not what counted in this competition. Most other rafts started sinking before they made it to the finish line. Nope, we took second place. We never managed to catch up to this one other team, but they just used a rubber raft from the store.
Correction. I found the raft in my house. Ergo, it is a household item. And prior to my spectacular victory, competition rules did not specify whether the...
Why are you dressed like a bug?
Now, there are lots of different variations of the engineering design process, but this one here is very similar to the one we just watched in that Brain Pop video here. So I'm going in a cycle here, starting at asking those questions of what the problem is and what limitations you have. Imagine next, imagining all the different possible solutions. That's where the brainstorming happens. Planning is where we actually sketch it out and make a list of all the materials we'll need. And then the fun part, creating, that's where we actually get to make it. And last is improve, where we improve and make it better. And sometimes in between that create and improve, we might see a step that says test or experiment. And that's all part of improving it as we see things that are wrong and are testing it out. Then we're improving it and go through that whole cycle all over again. For your Schoology assignment today, you'll look in the appropriate folders, week and day, and you'll just see two things, of course, the video, and then once you're done watching the video, part 2, it's an engineering design process quiz. And there are just 6 questions here, and each one of these questions are multiple choice here. Okay, so it's just asking about those steps and some of the things that you saw in the Brain Pop video. So that is it, just those 6 questions, and then we'll be ready to move on and start our design challenge.